Good afternoon, everybody, and welcome to the Hexagon Experience at MINExpo 2024. My name is Curtis Stacy. I'm the Senior Product Manager for Autonomous Drills here at Hexagon, and I'm here to show you a little bit of something about what we've done that's quite unique. So I started out in mining in 1991, 18 years old, right out of high school, went to work in a copper mine in southern Arizona. I was uniquely qualified because of my many years of experience to run one thing, a P&H shovel. Not the big ones. Mine was about that tall, had a pine handle on it. And I got stuck in a feeder pit in a concentrator shoveling fine ore back onto a belt. That job lasted 3 months. That job is still going on today. Somebody else is just doing it. I was terrible at it. I didn't know how to shovel. I hadn't been really taught how to do that. So it got me thinking, there's got to be a better way to do these things. And there really is. But we have a problem in the mining industry, and it sort of stems around labor. One of the issues we have is finding people that want to come to work in the mining industry so that we can extract these minerals and change the world that we have in front of us, right? Well, it turns out 70% of people aged 15 to 30 want no part of the mining industry. And that saddens me because my career's been amazing. I've been all over the world, every continent except Antarctica, doing this kind of stuff. Started out just shoveling dirt. On top of that, even in places where you can find people, you still have to train them. And it takes 10,000 hours for one person to become an expert at anything they do. 10,000 hours. That's 5 years of training to make them really, really good at it. So, maybe there's a better way to go about this. Well, it's my honor to actually introduce you to a way to change that. Hexagon's Drill Assist application. It's the first artificial intelligence powered drill automation unit. So we actually embedded the AI in the control algorithm. So the artificial intelligence is actually doing the work behind the scenes to find the best parameters for your drill for any given ground condition. When we set out to build this, we asked ourselves 5 questions. What if we could install this thing in 5 days? That was a design parameter. It had to be simple, a layer of technology. What if we could retain all OEM components? So we're not ripping out your system that's already on your drill. We're not replacing it. That drill, as an example, behind us here, we could put this thing in that drill and everything about that drill would remain the same. You would maintain it the same. You would operate it the same. You would do everything the same. Unless you were using our technology, you press a button on the screen and then all of a sudden the AI takes over and parameterizes that drill so that it runs more efficiently and more productively. So how long would it take to train an operator with a system like this? That was question number 3. 15 minutes. We can train your operator in 15 minutes to operate this system and not change a single thing about your site or any processes on it. And lastly, what if we could do all those things and give you 30% more productivity on your drill rig? Well, as it turns out, we did it. This data from a 3-month study shows we outperformed human operators on a Caterpillar 6420 by 70%. A 70% increase in the average rate of penetration on that drill using this technology. Now, normally, most drill automation systems have a hard time beating the best operators on the site. The guy that's up there at the top, pretty close to where we're at, 25-year veteran driller. He's in our videos. You can come watch him over there if you'd like. Not only did we increase productivity, but we lowered cost of drilling by, as a metric of cost per meter or cost per foot, by 24%. Lowered carbon emissions because we're doing more work with the same amount of energy. And just at the end of the day, it's more productive. Well, that's great. You can increase my productivity, but what are you doing to my drill? Are you tearing it up? Pushing too hard? Turning too fast? Well, as it turns out, one of the key, the leading indicators for drill stress is rotational torque on the drill bit. So we plotted, we tracked rotational torque on the drill running in manual mode and in automatic mode. And we saw a 40% reduction in overall rotational torque force on that drill bit running in auto mode, even while we're increasing productivity by more than 30%. Because it doesn't really make sense, right, that we could even do that, except that the reality is a given ground condition requires the correct set of parameters to drill it efficiently and effectively. That's the bottom line. You don't have to push too hard. You don't have to spin too fast. You just have to choose the right set of parameters. Well, what about my drill came with auto drilling already, right? How's this? Why would I replace what I've already got? Well, we did that too. Brand new CAT 6310 increased the effective rate of penetration 42% over the OEM automation. 42%. What does that mean? 42%. So if you have 4 drills on your mine site, you might be able to shut 2 of them down. At least one. We're starting to change the world now, right? Lower carbon emissions, increasing productivity, making your mine site more efficient, making everything about what you do more effective. But there's more. Data. Measure while drilling data specifically. It turns out when you run the drill with the incorrect set of parameters, you get incorrect data. The bar graph on your left-hand side, there's 2 holes shown here, top and bottom. The top one was drilled by the OEM auto drill system. The bottom one was drilled by ours. If you notice the red in the bar graph on the left, that indicates that that ground was hard. When in reality, when drilled with the correct parameters, the ground is actually soft. So if you're doing loading based on that data and it's wrong, you're putting too much powder down the hole and you're not getting an effective blast. So that's what we're trying to solve when we talk about blasting. And if you think about blasting at the start of the process and everything that happens downstream from that, the loading, the grinding, the milling, all of that, we can dramatically reduce energy consumption by getting it right in the beginning. But it's hard to get it right in the beginning if you don't have the data to do that. So how are we doing this? If you notice the yellow line and the magenta line on the OEM graph, there's very little adaptation occurring. It is not changing the pull down force, and it is not really changing the RPM as the bit penetrates the ground. Whereas with the artificial intelligence powered one, it's changing constantly. In fact, every 10 milliseconds, the AI analyzes all sensor inputs and makes a decision about how to proceed. That's great, you can do all these things, but what about my relationship with my OEM? Guess what? It's important to us too. We don't want to do anything that threatens your supply chain or your support network. So we built this as a layer of technology. Everything you had from the OEM remains. We are simply a digital operator. Our layer goes in over the top of it. It can only do what your operators can do. We can't do anything other than that. So your warranty remains intact. Your OEM maintenance processes remain intact. Everything about that drill before we touched it remains intact. So what if we can increase your productivity? What if we can make you more efficient? What if we can lower your cost per foot? What if we can do all of these things? And together we actually do change the world just a little bit for the better. I'm Curtis. If you'd like to come and speak more to me about it, I'm on the other side of that safety kiosk, and I'd be happy to show you everything I've got.